Hello students, in this video I am going to go through two exercises with you guys involving a technique called synthetic substitution, which is really a combination of synthetic division and the factor remainder theorem. Alright, so let's take a look. So synthetic substitution is actually a technique for evaluating functions using synthetic division, and I forgot to add, and factor remainder theorem. So suppose I have h of x is equal to this polynomial that I have on the screen right now, and I want to evaluate h of -2. So what you would do, okay, is you would go normally, and when I say normally, traditionally, this is what you would go through, and wherever you see x, replace that with -2 and proceed to evaluate this, right? And this would be very, very tedious if you did not have a calculator. So, so what we can do, okay, to get a general sense of what the actual numbers turn out to be, okay, there is a way of getting around this. So from the last video, we understand that if we wanted to figure out what h of -2 was, this turns out to be the remainder for the quotient of h of x divided by x plus 2. So if I were to go through and figure out what the quotient is, because sometimes finding out what the quotient is may be a little easier, and finding out what, and then after finding out what the quotient is, and then determining what the remainder is, we can then arrive at what our h of -2 is a little quicker. That's the theory, okay? So let's take a look. So if I go through and do exactly that, okay, I'm going to take -2 and apply the division rather than going through long division. I'm going to use synthetic division just because the process, there's less writing involved in synthetic division, but understand synthetic division also has its limitations too, because we can only divide by binomial that is linear, so and 1 and -5. So I'm going to perform the synthetic division here. And synthetic division says we're going to bring down that first coefficient, multiply -2 with 4, we get -8. Add 0 and -8, I get -8. Add -2 and multiply -2 and -8 together, we get 16. Add 16 and -1, I get positive 15. Multiply -2 and 15 together, I get positive -30. Add 0 and -30 is again -30. Multiply -2 and -30, I get 60. Add 60 and 1. Multiply -2 and 61, I get -122. Add them together, I get -127. So I don't really care for what the quotient is, but this, as it turns out, will be our remainder. So therefore I can say h of -2 is equal to -127. So you may be wondering, like, get out of here. We figured out the remainder without having to go through like substituting and replacing x with -2. You're absolutely right. And actually, just to confirm this, right, I already have this function graphed in the graphing calculator, which is right here. And if you take a look, right, that's the function there. And what I want to do is I want to press trace. I want to pop in -2. And that's exactly -127, right? All right, let's take a look at another example. So suppose I wanted to find out what the remainder was of, let's not do +4, let's do -1. Okay, so suppose I wanted to find out what the remainder of this function is, okay, and when divided by x minus 1. So the remainder r will equal to h of, is it going to be +1 or -1? It will be +1. And for this, something like this is simple enough where I can just pop in and figure things out. I don't need to use synthetic division. I don't need to use long division, because this is something simple enough where I can just pop in, right? So if I pop this in, I get 4 minus 1 plus 1 minus 5. So h of 1 will equal to negative 1. So the remainder will equal to negative 1. And if you're wondering, wait a second, is that even right? Okay, you can certainly go through the synthetic division and figure this out, right? So let's see here. If I take positive 1, 4, 0, negative 1, 0, 1, negative 5, and go through the synthetic division to find out what the remainder is, okay, let's see. I get 4. 4 times 1 is 4. 0 and 4 makes 4. 1 times 4 is 4. Negative 1 and 4 makes 3. 1 and 3 makes 3. 0 plus 3 is 3. 3 times 1 is 3. 1 plus 3 is 4. 4 times 1 is 4. Negative 5 plus 4 is negative 1. That is indeed our remainder. Look at that. Okay?